Right, so we're starting Fix It Friday for 15th of July. So we've got a couple of files to look at today that have various issues. The first one will be a semi-continuation of what we were looking at with Chellamore's poofs, the couch beanbag things. So if we just drop those into, let's open just in case, open, don't save. Which one is it? It's that one. Don't load the UI, open. Whoops. Okay, so is it that one? Where's the... No, it's not that one. Hang on. I think I loaded in the wrong file. There we go. That's what I wanted. Although we might need to load the original. So, Chellamoore was having trouble trying to set up. Did we hide the other ones? Yeah, so those are the originals. So Chellamoore was having difficulty trying to get the normal maps to work, or normal map baking to work. So in the last session, we were talking about how we can optimize. So this was the original. So how we can be more, let's just get rid of select all. Try to use this menus as much as possible so that this is easier to follow rather than using shortcuts. So last time we were looking at this mesh in particular from the point of view of how we can optimize meshes structurally such that they are not as heavy as the high-res versions. So you get all your detail from your high-resolution meshes, but for IMVU we don't want to be using those types of meshes. We want to use low-resolution meshes. So what we did was applied or assigned, is it still assigned? No, it's no longer assigned. We assigned the decimate modifier to the high-res, to the high-res, and then reduced its quality down to about, I mean, this shows what this actually, the principle of optimization is indicative of what we're going to see. So the original, that's for both of, let's isolate this one actually. Isolate that. Use the shortcut. Use the menu, separate selection. Right, so that's the original. So it currently stands at 14,000 polygons or faces, triangles. And what we want to do is reduce this to a game-friendly version. So when we're talking about high-resolution meshes and how inefficient they are, we can see this in this process. So I'm going to decrease the ratio, which will decrease the density of the mesh, and we'll see that we can lose quite a significant amount of mesh structure before we even start seeing any significant change to the mesh. So instead of it being 14,000, we get down to about 8, 9 before we start seeing visual artifacts, but we've not really lost much detail. And we can keep going until we're about 2000, well, 2,500, and we now start to see a drop in the detail that's associated with the mesh. But for the game mesh, we can go even further down to, so that's 400, that's a little too low. 800 is about okay. With something like this, around about 1,000 is fine. And we keep the shape and form and general structure of the mesh, but it reduces, we're not using the, as it was, 14,000, which doesn't really give us much, I can't think of the word, doesn't give us much, it's not as optimized, and it's wasteful in the sense that we can use, so if we drop this right down to its 1,000, so we're at 1,090. If we use the normal maps, which we'll do in a second, if we use normal maps, we are now gaining, what is that, 1,000 from foot, so we're gaining 13,000 triangles that we could use for something else. And that's what the optimization is really all about. It's not just necessarily that we're making low-res versions of everything. It's that it allows us the flexibility to utilize the, well, it's not waste per se, but the excess for other things. And that excess can be quite significant, as in this case, that's a drop of 13,000 tris. So we've gone down to 0.05. So that's probably about 1% of the original. But, so that was what we were talking about in the last session. But today, what we're going to look at is baking the normal maps. So what we might have to do is just rebuild a low-res version of this sculpted high-res. So we did that before. So as an alternative to using Decimate, for shapes like this anyway, it's often just easier to just, so where is it, cylinder, oh hey Cameron, hey Esme.
Hello.
Welcome. Just going over some, well, today we're just going over some meshes that people are having problems with. So right now, just talking about optimization, and just going to bake a normal map, but I first have to make a low-res version of Chellamore's couch. I have to do that again because I moved that. Mesh, cylinder, whoops. So let's try 18. Just going to move that into place, roughly scale it up. So we don't always need to use Decimate to create low-res game meshes. So for some furniture items like this, it can be relatively straightforward to create, whoops, that's what I want to do, edit mode, into there, so just do some basic editing. So remember last time we were talking about how we can use the widgets to manipulate surfaces, but we have the different orientations that we can use, which allow us to rotate on particular axes. But when we are meshing something that's off axes, what we can do is align the view to the angle that we're going to look at, and then use the white loop to manipulate along that axis. And that means that we don't have to spend a lot of time using the ordinary axes, the red, white and blue, the green, blue and red ones, which we have to then keep fiddling with to try and orientate the mesh, the selection. We can just orientate the view how we want the selection to be manipulated and just manipulate it.
I gotta take this.
That's all right. Add the loop cut in the middle. No, we don't need one there. And the bottom.
Veterans.
Oh.
Thought it was my doctor.
Oh. And bevel. Select a loop. Bevel the top. Bevel the bottom. Face. Inset. Drop that down, and again wireframe. Actually, that might be okay to just drop that straight down. Using the white loop again. Like so. Maybe another inset. Edge select. Drop that down, and that is going to be, well, we might expand that a little bit. Drop an extra, oops, it's a very sensitive tool. Scale, that should still be selected. So we might have to do a little bit of manual manipulation around the back. Just hide that so we can see. Hang on a sec. Right, so that'll do for our low res. So for the sake of the normal maps, we just need to get this approximate. Doesn't need to be exact. Like so. But we do want to keep the general shape. So that's going to be our low res. So let's just rename that. Double click. Double click. Call that high. So smoothing. Where's it gone? Oh, I was right over it. Smoothing. Make sure smoothing is on for the mesh, the high res. Right, so next thing, we need to unwrap this. And it will already include a default UV map, which we might be able to use. So let's just double check that we have a material. We don't. So new. That's the preview. Rename this B-bag. Don't need anything else there. So shading workspace. There's our material basics, and to this we just want to add a texture, image texture. Drop that into place and create a new image. Beanbag. Width 512, height 256. Oops. Generated type. Set that to UV grid or color grid, it doesn't really matter which. And then OK, and connect color to base color. So color out to base color in. So it's included the default UV map, so we can maybe do just a little bit of tweaking to that. So what we want is, when we're doing the UV map, what we want to try and do is as mentioned in the previous session, what we want to try and do is not necessarily hide, but we're going to have to put seams on this anyway. What that basically means is that we're going to have these hard breaks around the mesh at various points because of the shape of the mesh, and we're trying to basically smash a round peg into a square hole, and obviously we're going to break the toy if we do that. So because we have those and we know we're going to have them, what we can do is utilize the shape of the object and place seams that will break the mesh up so that we can disguise or hide the UVs, the seams between the textures, the areas of the texture, and we hide them naturally within the shape of the object itself, or by the shape of the object itself. So in this case, we'll do a loop select around the edge. So at the moment, this top edge is where the UV map has been naturally broken by the default UV. But what we want to do is just include this lower loop, which is where you would naturally find, well, I would hope you would naturally find, if it's a decent furniture maker, you would find the seam between the sides and the top, because you don't want your legs hanging over the side here and being interfered with or irritated by this seam that would otherwise run around the top. You want that out of the way. And for something like this, the best place for that would be the next loop down. So we'll select that all the way around, edge, mark seam. So that'll mark the seam, and then we'll do the same again on the bottom. So for this we can just select the entire bottom, mark seam, and then we want one down the back again that kind of naturally replicates where one might be for an actual object like this. Mark seam. So what that does, when we unwrap this, where's our texture? Oh, we've got two beanbags, so let's just call this brackets painted. So we can rename this one just beanbag. So we can select all. So that's the default. So that's what comes with the mesh primitive. UV unwrap, and that'll unwrap it like so. So that's our top. Actually, one thing we forgot to do before we do that is just to double check. Object mode, object data. What we want to do is check scaling of the object. So we need to change this, well, not change it, we need to reset the mesh so that it's scaled 1 to 1. At the moment it's upscaled. So we want object, because this affects the way UV maps map out. So if we keep an eye on what this is doing, the shape of this, object, apply, it's rotation and scale. Yeah, rotation and scale. That resets. Everything's back to 1. So if we now do the UV map again, it'll probably change the layout. Yeah, let's change the layout a little bit. Oh, that's okay. So let's organize this and do a little bit of editing. So what we're going to do is edit the shape of this. Use the shortcuts for this because it's easier. So scale, Z, oh no, that'll be Y axis, and then 0. No, it's not Y, it's X. So scale, S, along the X axis, so X, and then 0 to straighten it up. So we can pin these. So we pin those, do the same on the other side. So loop select, S, scale, X, axis, 0, and click to confirm. Pin. Let's just pin these so we don't mess with them. And then unwrap. So we can do UV unwrapping from the UV menu in the editor, UV editor, and or the 3D view. UV unwrap, unwrap, and that straightens it out a little bit. So it then becomes easier to do S, scale, Y this time, Y axis, and then 0. And we can do that for all of them. S, Y, 0. S, Y, 0. Whoops. 0. S, Y, 0. So all we need to do now is check the displacement. And of course, because this is a long shape, we are limited in how much space we can use if we are going to bake normal maps. So that's the top and that's the bottom. It doesn't really matter about that. And then, as we mentioned before in the oops, that's upside down, so let's write that the right way up. As we mentioned in the previous session, we've got some space left over that we could use for other things if we wanted to. But that's the basic low res. And that's the high res that we'll use to just bake some simple normal maps. Whoops. Right, so let's save this before we go any further. Fixed 2, and then we'll bake a normal map. So for that, we need to make sure that our two objects are in the same location, which they are. And then we also need to switch the render engine. So that's this. So we're in render properties, and we need to switch from Eevee to cycles. Won't necessarily see much here, but down here we've got a different set of properties, and one of them is bake. So we expand that and we've got all these options. The default is combined, so that combines all the maps together into one image, but we want normal maps, so click on bake type and then select from the list normal, or whatever bake image you're going to produce, but in this case we'll just do normal. That'll change the settings, and then what we want is selected to active. So enable that, and we'll get two additional options of it. Well, there's actually more, but we'll get two additional options, and the one we kind of want, we need to pay attention to or be aware of max ray distance. We might have to adjust this, but we'll see once we've done the bake. Everything else is okay. Tangent space, these axes are okay, so we don't need to do anything with those. So leave those as the default. Then all we should be doing is, let's switch to UV editor so that we can see the result of this. So we select the high res first, shift click the low res, and then in render properties, expand the options again, and we should find that we bake a normal map if we just click on the bake button. So we've got normal, tangent, that's okay, selected to active, that's okay. Right, so bake. Let's see what this does. There we go, there's our normal map. It's a bit wonky at the moment, but that's okay. So we got a little, don't know if you noticed, there was a little error message that popped up. Circular dependency for image beanbag from object low. So we can fix that. Shading, just decouple the image texture from the material. That's all you need to do for that. And it'll still bake, but the image won't necessarily appear on the object itself. So high res, low res, let's just double check that that's the case. Yeah, so that, yeah, there's no error message. It's because it does that because we are baking to the image that's also actually being displayed on the object, and that's where the circular reference comes from, because it's trying to bake to the image whilst it's displaying it at the same time. So it does this That's where the circular loop comes from. But if we pop that back on, we can see the normal map on our object. But the funky colours are to do with, and this is why we need to pay attention to the max ray distance. Because of the shape of the object and it being a low res, these colours, they occur because our low res is clipping through the high res, and where that happens it causes these miscalculations, for one better way of putting it, miscalculations with the way that the surfaces are being interpreted as structural colours. Because what we want are all these bluey purpley colours. We don't want these greenish reddish ones. Those are bad, these are good. So the way we fix that is we adjust the max ray distance, and we may not need to go too high with this. So let's just go to 0.1 and see what that does. So high res, shift click low res, rebake. There, we've cleaned it up. Might need to do it again just to, or the alternative, whoops, is to use extrusion. So there are different ways to solve the same problem. So let's zero that. Do a similar thing. So high res, low res, bake. So it does a similar thing, but in a different way. Let's increase that a little bit more to 2. Try that again. And a little bit more. And there is our completed normal map. And you might notice that there's actually a difference. So let me just do a quick screen grab of that. So, whoops. Screen grab of that, drop that in chat so there's a reference to it. So this is a normal map extrusion. And this is normal map max ray distance. So we'll keep this zoomed in on this area because we can see the detail. Notice the difference. So this is normal map max ray distance. So it's not always necessarily going to be a one fix. What is it? One fix alls. No, that's not. Well, you know what I mean. It's not the one thing that'll fix everything. So play around. If you get the odd colours that we were originally had, you can play around with both of these settings, extrusion or max ray distance, to get what you need. So what was it? We got 0.25, I think. So in this particular instance, with this particular shape of object, extrusion works better. And that produces our normal map, which is now assigned to our object, which we can now, so let's apply, we've got a grid text, oh that'll do. So that's a plain grey. Let's hide the high res. That's just a plain grey texture. So there's nothing there. Let's utilise the normal map. We might need to save it, but add texture, image texture, drop that into place, connect the colour output to normal input, and we should have our normal map in our browse image to be linked list. If we don't, yes, there it is. So it has assigned it, and we can see the detail of the normal map on our object already. Hang on, let me just frame selected, there we go. But it's not quite right. So to fix it, we need to do two things. Oh, it's automatically never noticed that before. Add vector normal map. So we want to instruct Blender, this material that we're assembling, that this is a normal map. So we get one of these, drop it in between the two, and it sorts out the normal map. I'm not quite sure. Oh, that's why. So what we do need to... What we can do is browse image to be linked. There is our normal map. We'll save this. Save as beanbag normal. Select our format, a lossless one preferably, so Targa Raw, TIFF, BMP. Everything else is okay. Save image. So now it's changed some of the properties because we were using a rendered, temporary rendered data. What we want to do now that we've got color space available, whoops, is change that to non-color. So if we watch, so we can see that it looks a little bit faceted as we move the object around the scene to interact with the light. So if we set this to non-color, it corrects and renders correctly. And that is a normal map. That looks quite good actually. Well done, Chellamore. Very nice mesh.
It looks incredible.
It does. That's actually quite nice. So that's the high. And that's the low. Oh, that's the low. Let's turn the colors back on. But that is baking normal maps. But if you want to bake something else, it's exactly the same process. That looks actually quite good. Well done, Chellamore. So if you want to bake something else, it's the same process, but you just choose a different bake type. So we could do ambient occlusion, for example. That's a good one for textures. That gives you your shading layer. And again, enable the high res. So high res, shift click the low res. We're going to render. Oh, we are in render properties. No, let's go into. There we go. UV editing. And then bake. Let's see what this does. Right. Okay. So this time, that's right. Depending on what you're doing, you don't necessarily need, for ambient occlusion, don't necessarily need to have the high res visible in the scene. But if you want to disable it for ambient occlusion, what you'll need to be aware of is that other objects that are in the scene will affect the ambient occlusion, because ambient occlusion is baked relative to what's in the scene. So if there are other objects influencing the way that the illumination of the scene is influencing the mesh itself, we need to make sure that those are hidden. Well, they don't necessarily need to be hidden per se, but we need to make sure that they are not rendered. And for that, we click on the little camera icons. So we have to disable. Whoops, no, we don't want that. We have to disable render for all the objects we don't want to see. And hide the high res and rebake. We don't need selected to active for this. We're just baking the ambient of the object itself. So make sure it's selected, bake. And there we are, there's our ambient occlusion. And we would then save that image, save as beanbag roll. So this is ambient TGA. So again, set your format, save as image, and you would use that as part of your texture. I mean, to the extent that what you could also do is, for ambient occlusion in particular, so the textures that you would see, so that could be ambient occlusion or your diffuse, for something like this that's essentially sat on the floor, what we could do is this. We don't necessarily want that to be too close, so we can just move it out of the way for a little bit, select our object, bake. That now influences our mesh. But we do need to be aware of ambient occlusion does have a habit of faceting, and I've no idea why it does that. Let's try active to selective, see if that actually makes a difference. So we're going to use the extrusion setting we used before. I don't think it does, but yeah, it doesn't like that. That's the one bugbear with Blender, is that ambient occlusion renders the facets of our low-res objects. I have no idea why it does that. Don't know if it's, I don't think it's because of these objects that are in the scene, because it wasn't necessarily doing that before. Whoops. Let's hide that, hide that. Yeah, so that's our object. So you'd have to do some tweaking. I mean, it's interesting that it does that because, I mean, frankly, it shouldn't. The object is set to smooth, but this is a long-standing issue with some of the maps that you bake in Blender. So just be aware of things like that. But, I mean, the normal map, let's load that back in. And change the non-color. That's it. And there's our normal map. So that at least works. So maybe this is where you would, if you had access to Substance Painter or something like that, you'd use Substance Painter. But it's kind of goofy that it's always done that it doesn't like... Well, it always renders the facets of low resolution meshes. But that is baking. Well, it's a furniture item, but it applies to everything else. So that's our baking file that we need to look at. So the next file, if I can find it, now this one might be tricky. Reset. Oh, you don't need to save that. Open. Is a weight painting issue. Which one? Where is it? No, that's Roy. That's the next one. Is that it? Oh, that's it. Right, okay, that's the one. Load UI. So, if you disable, if you're working with somebody else's files, click on Settings and disable Load UI. And what this will do is it'll reset the view to use Blender's defaults rather than the interface defaults or the interface shenanigans that might be brought in with the file that might be confusing and might be causing issues in their own right. But so disable that, and then it'll load it, or it should load it. Where's the file? Oh. What's he done here? Let's just select all. Frame selected. Oh, it's big. Okay, so reset the view, scale 100. View 1, 5000. There we go. Should be able to see that. Not quite sure why that's hidden like that. Object. Show hide. Show hidden objects. Nope. quite sure what's going on here. Let's have a look. There we go. Okay, so I don't know whose... Oh, yes I do. I know whose file this is. Right, so pose mode. Got the selection skeleton selected. So this is going to be based on what conversation I had. So we've got some stray vertices or mesh deformation, whoops, caused by some vertices not being weighted. They're either not weighted or they're incorrectly weighted to a particular bone. So what we can do in this case is, whoops, we can deform the mesh to an extreme. So we can see what's going on. Select the mesh, skeleton, no, it's the other way around. Skeleton first, then the mesh, then switch to weight paint mode. So object mode, weight paint mode. And then we can check, so we can see that these errant vertices are causing, so they're probably supposed to be associated with spine 04. So we've got this coloration at the top here, which is spine 04, so that corresponds to this upper section of the mesh, and these vertices, or these errant parts of the mesh, look like they're supposed to be part of this section of the mesh, but they are not coloured, so that means that they are not being influenced by that part of the mesh. And that's all we needed to do. So strength, that looks to be 0.5. That might be a bit too strong, so let's go 0.125. Still not, might not be enough. 2.5. So it looks like yeah, so that's what that error was. So it's just a matter of distorting the mesh to an extreme in order to expose these kinds of errors or omissions, and then correctly weight painting them. But how do we do this in... Yes, I can't remember if we can do it that way, but it's just a question of deforming the mesh to an extreme. That's still quiet.
But thank you for showing me how to mesh.
Oh, that's all right. Anytime. Bye for now. Right, there we go. Was using the wrong, it's changing strength instead of weight. But that's how you fix those sorts of errors, is deform the mesh into an extreme pose, see what pokes out, and then select a bone relative to the area you suspect is causing problems, and then just weight it. So select all, Alt R, Alt G. And we should find that deforms and poses correctly now. Still a little wonky, but it's just a matter of, so we've still got a little bit of wonkiness, but it's just a matter of checking the bones and the weight painting. So that's file number 2. And you've got to watch out as well that if you make a mesh that's relatively dense, you're going to give yourself some serious headaches, especially when you do things like this. So just be aware of that when you do these stacked planes. They are an absolute headache for weight painting. But that's file 2. So let's just save that, save as, fixed. And then the third one is Roy has a cape. Reset. Roy has, oh, I have to use a different version of Blender for this. So we're going old school. 2.79.
I got a dip as well.
All right, see you later.
Yep.
So we're old school now, and we want file open. Whew, can I remember how to use this? Up, up, up. There we go. Load UI, just disable that again. So all versions of Blender generally have that. So you can disable that just to make sure that you are just bringing in the file data, so the mesh data, or whatever it is that's included in the project. You don't want the interface. So open Blender file. So we have to reset the view as always. Oof, this is quite a complicated mesh, Roy. No textures, materials. So this is an accessory. We need to check dope sheet to action editor. Home, so that we can see the entire. So what should be happening is the cape flutters or animates. So let's just hide the bits that we don't need. Oh, I see what's going on. Okay. Yeah. So this is our cape accessory. So this is an accessory item that's animated. So this, for this to work, yes. Okay, so this is a cape. So let's assume that it's going to anchor. So even though it's positioned up at the top here, let's see if we can change the scallywags appearance. Again, I have to remember where stick, B-bone. Let's just use stick. Here. Yeah, so this is an accessory item. So how it's animated as a... Oops, we have to also then set the... Where's the clip distance? It's been such a long time since I've used this. Well, at least this version. That's clip distance. There we go. So this is an accessory. It's an animated accessory. So for this to work, it's positioned where... Which one's the mesh? No. It's positioned where it needs to appear, at the shoulders. And the skeleton is obviously set up so that that can animate. So this stuff is okay. There's nothing wrong with that. When you're doing accessories and animated accessories at that, the root, if we are using these older files, we need to make sure that the root bone is called, now what is it, attachment dot root, but that has to be positioned relative to the point or the bone that's going to act as the anchor for the accessory item. So this is positioned relative to the cape but not the avatar. So this bone needs to be positioned at one of these bones, and it needs to be correctly orientated with respect to the orientation of these bones also. So the easiest thing for that is usually, whoops, that's the wrong one, is usually to duplicate again, this is not one of the starter files that CatSpits has available. This is a different. This is from someone else. You basically have to duplicate one of these bones because they are in the correct orientation that's necessary for output to IMVU. So this bone needs to be positioned at this bone and pointing in the same direction, and that's your anchor from which you then arrange the bones of your accessory for whatever the accessory actually is. And it doesn't necessarily need to be connected to the actual animated part of the accessory. It just needs to be linked virtually, so there's no connection between these two bones either. So what you have to make sure is that what we want is for there to be a connection, a link between the bones in the same way that, or in a similar way, not necessarily the same way, because these are not attached or connected bones, but there needs to be a relationship. So we can check that by selecting the bone, and bone properties. Again, I have not used this in a while. And we should, there we go, bone 15. So this bone has no parent. It should be parented to attachment root. So we select it, set attachment root, and we get this relationship line appearing. So that now confirms that there is a relationship between the two bones. Same for the other side. And then with this bone, once that's in position and where it needs to be, so let's assume it's going to be connected to this bone. And we need to, where are my manipulators? There we go. I'm just going to roughly position this where it needs to be. Which bone did we want to use? Was it this one or this one? I think it was this one. So we're just roughly positioning it. That is our anchor point. So the skeleton for the accessory is then related, or properly relational, to our root bone. And this sits at the top of the hierarchy and everything else sits below it. And that should then export and position itself correctly in IMVU. I won't do it in this version of Blender because I can't remember how to do that because it's so long ago since I used that. But that is file number 3. So it's the, pardon me, it's the bone setup. The naming convention for this version of Blender and the skeleton that's being used, and the relationship between the bones to complete the hierarchy. Where's the skeleton for this one? Here we go. So we can see attachment root is now at the top of the hierarchy. So when that doesn't have a parent or a child associated with it, we can see how the relationship changes. Like so. So the naming of the bones isn't necessarily the issue, it'll be the relationship. So we need to always make sure that we have a fully configured hierarchy. which we can then expand. That's the left side and that's the right side. And if you want to make it easier so that you're not staring at numbers, what you can do is just, let's just go into hide the mesh. Let's just select our bones, bone properties. Oops, that's that one. And then we can just rename these. So like cape, cape left, so cape dot L dot 00, well that's 012, so let's just use that 012, and you just go down the list and change the L dot 004 so that you have a better idea of what you're looking at when you are L dot 15. So that's changed the name. But that's incidental. So that's what that issue was. So that's file 3. So 3 files for today. Normal map. Normal map. What do we do? Normal map. Yeah, so we picked a normal map, sorted out mesh rigging, and then we fixed a cape. How do you unhide things? It's been way too long since I used this. Let's just unhide it like that. And the cape in an older version of Blender. Right, so we'll call it quits there for Fix It Friday for the 15th of July. And we shall see you on the next Fix It Friday, next Friday, whatever the date of next Friday is. Right, bye for now.